Hi, my name is Shreyas and I'm representing Team Aarohan for the MIT VPU SAMVED team. And we are presenting our solution for the problem statement 4, which is Smart Safety and Assistance System for Sanitation Workers of Solapur Municipal Corporation. In our system, we respectfully call the sanitation workers as Swachhata Veers because they are the real protectors of the city's health and the overall hygiene. Our solution is called Veer Suraksha Grid. It's a practical, budget-friendly, and implementation-ready system that improves the safety, accountability, and the governance in the sanitation operations that we have been seeing till now. It's a practical, budget-friendly, and implementation-ready system that improve the safety and accountability and the overall governance. The goal is simple: no blind entry, no unpromoted risk, and complete protection for Swachhata workers. So, talking about the problem definition, I'll switch to this. So, we have given the problem context here, as you can see. Let me explain the problem to you very clearly. So, Solapur Municipal SMCs manages around 246 kilometers of underground drainage system, but nearly 49% of the population still depends on the normal sanitation systems. Also, more than 220 slum areas, as you can see here, have very narrow links and where a large mechanical vehicles cannot enter. And because of this, manual entry still happens. And when Swachhata Veers enter, they confirm confined spaces that are there in over there. They face toxic gases like H2S and methane. Low oxygen levels are there. Sudden flooding is there. Structural collapse is there. Long-term health risk may happen to them. Even though Maharashtra started the manhole to Machinehole initiative to promote the mechanic learning, there is still a gap between the implementation of the program which was started. There is no longer integration system that checks the risk before the entry, whether the sewage that they are entering is clean or not, or whether the risk is worth taking to enter that or not. Monitors live the environment data. No one monitors the live environment data, tracks machine usage, enforces the digital approval for that, and there is a gap that we are solving. And what we want to achieve is our objectives are practical: reduce the blind manual entry for them, ensure that real-time gas and oxygen monitoring is there on our systems, make superior approval mandatory for them, and promote machine based first approach rather than people entering the manuals and then doing the work themselves, and protect the Swachhata Veers with dignity and give them some respect. Okay. And over time, move from the reactive compliant based cleaning to some preventive AI based planning. So I'll explain you the overall architecture now. Just a minute. Yeah, I'll explain you the overall architecture now. Our solution has five major layers: field sensing layer, robot and machine layer, communication layer, digital and intelligence core, authorization and governance layer. All of these layers work together. The first layer is field sensing layer. As I said, this includes the Veer guard, which will wear the wearable safety device, Veer Pro, which is our smart pre-inspection kit that we will give to them. These devices will collect the real-time data like gas levels, oxygen levels, water levels, worker location, SOS alerts, and this will ensure that the ground level monitoring is there. The second is robot and machine layer. This will include the Veer crawler, the portable robot inspection unit. Fleet monitoring system would be there. Before sending a human inside, will the machine will inspect it, and this supports the manhole to machine initiative which is taken by the government itself earlier. The third was, as you can see, a communication layer. All devices are connected to a gateway system. Even in an underground areas, data is transmitted securely to the central system that will be built. If network fails, the data is buffered and sent later, so the data is not lost basically. The fourth is data and intelligence core. This is where the main intelligence works. It includes V registry, V risk, V vision, and V planning. Let me explain you this simply. So this is a digital database V registry that we'll create for the manholes. We'll divide the Solapur city zone wise on the map. Each zone has mapped server assets with the GPS location, cleaning history, gas history, and the incident logs which would be there. Over time, as more of the data is collected, our system becomes smarter. We risk this engine evaluates the risk. A risk score will be given to each manhole based upon the gas history, the industrial area, the flood history, and the delay in the cleaning. The Veer Vision, this processes camera feed from the robots that will be sending into the manholes or detect like blockage density, structural cracks that would be there, water turbulence, chemical foam, and gives like hardness results to it. Just a minute. Yeah, and will give the hardness results to it. Next, about the authorization and governance part. Just a minute. Yeah, just talking about the authorization. This includes the Veer Pass, which I told you is a digital entry authorization for them. The Veer Black Box, which is the incident logging. Swachh command dashboard would be there. No Swachhata Veer enters without a risk score. PP confirmation, machine attempt, and superior approval, and everything is recorded. This adds the transparency and accountability that will be providing to them. The parts is integration with SMC infrastructure that we'll be doing. Our solution integrates a SMC existing system which is built in Solapur. If a citizen raises a complaint to the grievance portal or the WhatsApp bot or a toll-free number, then the complaint automatically links to the mapped asset that we have in our V registry. The system then will assign the risk score, schedule inspection, track the resolution of it. So we are not replacing the SMC system which was previously there, but we are strengthening it. So I'll just show you the Tinkercad hardware that we have built, just to give you a demonstration of the hardware that we have been building. So this is the Veer crawler, the robot inspection. We'll be building IoT part further for this hackathon. Veer guard, variable safety system. Veer probe, which is the smart inspection kit. Then we have Veer Vision and ICCC integration, the intelligence layer that I already talked to you about. So this over there. Final deployment will use rugged waterproof industrial hardware devices that we'll be work on. But this is just to show that we have started planning about the implementation for this and we are serious for solving this issue. Next part, I'll talk about feasibility and budget. Uh, just a minute. Yeah, feasibility and budget. Our solution is budget conscious. We'll use affordable components. Can be deployed zone wise in the phases that I talked about. Integrates with the existing ICCI CCC infrastructure and allies with the manhole to the Machinehole scheme that I talked about. So SMCs does not need to create a new system. We just strengthening the existing system which was there. We just like enhance the existing solution. Talking about the impact, and benefits. For Swachhata Veers, safer work will be there, fewer incidents would be there, more dignity would be there. For SMCs, what it would be there is better monitoring, less liability, smarter planning would be there. Then they would have less overflow would be there for them, and over time, fewer complaints because problems are solved before they will happen. Okay. So I'll come to the final closing of this. In simple words, our Veer Raksha Guard. So let me talk about the research and reference. So these were the research and reference that we took from. Yeah. So Veer Raksha Guard protects the people who like protect our city. It supports the government policies and the infrastructure which is already built. It strengthens the SMC infrastructure which was already built, and it moves sanitation from reactive to a preventive measure, and it mostly protects the Swachhata Veers which are helping us to like strengthening the overall system. So thank you, and that's what I would like to present for our solution or the problem statement that we have been working on throughout on this journey. And I have a very grateful to the team and the whole institution and organization for giving me this opportunity to like me researching on a very deep solution and providing